So in this session, we are going to discuss condensation polymers. When a condensation polymers form, that is through a condensation polymerization process, it is also known as step growth polymerization process. It is a polymer form when a reaction which consists of monomer having at least two functional group react by elimination of simple molecules like water, alcohol, etc. and form a large polymer known as condensation polymer. In this process, each step of polymerization is independent of each other. Hence, it is also known as step growth polymerization or step reaction polymerization. The next, we are going to discuss these condensation polymers in four different points: the structure of the polymer, how it is prepared, few properties, and then application of the condensation polymers. Now let's begin with the first condensation polymer, polyester. Example which we are going to take here is pteryline. First is the preparation. The monomer is prepared by transesterification of ethylene glycol and dimethyl terephthalate. Both of these are taken into 2:1 proportion. The monomer which form by the condensation of ethylene glycol and dimethyl terephthalate is then polymerizes at 280 degrees Celsius in an inert atmosphere, and we get the molten polyester. Then the molten polyester is extruded in filaments and spun into a fabric or fiber. The reactions are represented here. The first, ethylene glycol, 2 moles of that, condensed with the dimethyl terephthalate. At 150 degrees Celsius, we get the monomer with the loss of methanol as the condensation proceed. The second step, the monomer form undergo polymerization at elevated temperature 280 degrees Celsius in vacuum or in an inert atmosphere, and a polyethylene terephthalate or pteryline is formed. Properties. These polyesters are having good tensile strength. They are resistant to abrasion and crease. Generally, the polyesters are insoluble in organic solvents. They are also resistant to soap and detergent. Talking about the few applications of polyesters, the important applications is in the textile industry. The polyesters are used to prepare blended fabric with cotton and wool, namely polycot or polywool. Okay? That is the blended fabrics which are prepared when we use polyester with these natural fibers like cotton and wool. The polyesters are used for the preparation of thin films, which are used in photographic films and magnetic tapes. Next, condensation polymers are polyamides. These polyamides are classified on the basis of number of carbon atom present in each monomer. For example, nylon 6, nylon 6,6, and nylon 6,10. The number 6,6,6 and 6,10 indicate the number of carbon atom present in each monomer that undergo polymerization to give polyamides. The first polyamide which we are going to discuss is nylon 6. So first is how it is prepared. preparation of nylon 6. The monomer epsilon caprolactam, which is required for the preparation of nylon 6, is obtained from cyclohexanol. The cyclohexanol is oxidized to cyclohexanone, okay? And the cyclohexanone, when treated with hydroxylamine, gives cyclohexanone oxime. We all know that oximes can be rearranged in a Beckmann rearrangement reaction to amides, and here the cyclohexanone oxime on Beckmann rearrangement gives the monomeric unit known as epsilon caprolactam. Then the polymerization of the monomeric unit takes place at 260 degrees Celsius in an inert atmosphere, and which results in the formation of nylon 6. The reactions can be represented like this. The first reaction here represents a sequence for the preparation of monomer, that is epsilon caprolactam. Here you can see cyclohexanone oxidized to cyclohexanone, then the oxime formation, and which on Beckmann rearrangement gives the amide, cyclic amide called as epsilon caprolactam, which then undergo polymerization with the opening of this amide or opening of this lactam gives in nylon 6. Few properties. Okay. Now let's discuss preparation of nylon 6,6. The monomeric salt or nylon 6,6 is prepared from the condensation of adipic acid with hexamethylene diamine. The monomeric nylon salt is then heated at 280 degrees Celsius in an inert atmosphere, which polymerizes to nylon 6. The reaction for the preparation of nylon 6 can be represented here. Adipic acid and hexamethylene diamine undergo condensation reaction with the loss of water molecule. Here we'll be getting a nylon salt, which then polymerizes to nylon 6,6. Here both the monomeric unit adipic acid and hexamethylene diamine contain 6 carbon atoms in their structure. Therefore, the name is nylon 6,6. Now let's discuss properties of polyamides. The polyamides are having good tensile strength. They are resistant to abrasion as well as crease. Polyamides are elastic in nature. Okay? We can apply stress and the filament can be elongated, okay, up to 3 to 10 times of its original size. Applications of polyamides. It is used in the knitted fabrics like hosiery, socks, etc. The polyamides or nylon fibers are used for the preparation of ropes, tire cords, fishing nets, and also it is found in the bristles of toothbrush. So these are the various applications of polyamides. Next are polyurethanes. These polyurethanes are the esters of carbamic acid, that is carbamates. How they are prepared? When a diisocyanate condensed with 2 moles of ethylene glycol, the polyurethanes are prepared. The preparation can be represented with this reaction. Here we have a diisocyanate. This N double bond C double bond O is isocyanate functional group, okay, which condense with the ethylene glycol or alcohol and gives carbamate. These are known as esters of carbamic acid. The carbamic acid is NHCOOH, okay, and when it is esterified, we get the carbamate. So this is how the condensation reaction of diisocyanate with ethylene glycol results in the formation of polyurethane or the condensation polymer. Properties: polyurethanes are having low melting point. Usually, the melting point is below 150 degrees Celsius. These polymers are flexible in nature, okay, and they can be used for the preparation of flexible films. There are various application. Important application of polyurethane is in the manufacturing of spandex. We all know that the spandex is used for the sportswear, okay, or active sports fabrics. The polyurethane is also used for the manufacturing of upholstery material for the sofas and beds. It is called as U foam. It is used for the insulating laminates, also for the coating of furniture and rubber articles, etc. Next condensation polymer is polycarbonates. These are the esters of carbonic acid. A dihydric phenol is condensed with phosgene, okay, which gives a diphenyl carbonate, and polymerization in vacuum gives polycarbonate. The preparation sequence can be seen. Okay. When we use phosgene and it undergo condensation with bisphenol A, dihydric phenol, it gives a polycarbonate known as lexane. With the loss of small molecule like HCl, as this is a condensation reaction. Okay. Now phosgene is a gas, and instead of using that highly poisonous gas, new diphenyl carbonate can be employed, which again undergo condensation with bisphenol A, dihydric alcohol, and then gives lexane formation. Here, the phenol is eliminated in the condensation process. So, these are the two reactions which represent the preparation of polycarbonate. Either phosgene can be used with bisphenol A, or if we don't want to use the phosgene, then diphenyl carbonate is a safer option, which condenses with the bisphenol A in the vacuum conditions. When we talk about the properties, the polycarbonates are lightweight and transparent like glass, and this makes it very special. These polycarbonates have high impact strength and high melting point. These are resistant to chemicals, acids, and alkalis. And because of its transparent nature, when we talk about the applications of these polycarbonates, they are used for the preparation of safety glasses, which are used in the helmets, goggles. Also, the bulletproof glass, because it has high impact strength. And there are various applications of these polycarbonates.